Hello, thank you for joining us today. Today we'll be covering how to optimize production processes with asset data. Everyone's on mute, so if you have any questions during the presentation, please feel free to put them in the chat. There will be a short Q&A after the presentation. Our speaker today is Michael Hart, who is the Senior Director of Product Management at Plex by Rockwell Automation. All right, Michael, it's all yours.
Thank you, and good afternoon, everybody. As I was telling my fellow Plexians here, I got to be a little bit honest with everybody. I'm a bit frustrated this afternoon, so I'm happy to be joined by everybody on the phone. The reason is I was scheduled to play some golf with a good friend tonight, and he just called and canceled. So, the background is my friend owns a successful bakery in town here that supplies baked goods to local restaurants and cafes, and he had to cancel our plans because a few days ago his ovens malfunctioned and the temperatures started to fluctuate, resulting, as you can imagine, undercooked and burnt batches of baked goods. This led to customer complaints for him and wasted raw materials and ultimately loss of revenue. So as a result, he called in his maintenance team to fix those ovens, but the same issue unfortunately happened again today, creating a cycle of equipment breakdowns and reactive maintenance, resulting in significant disruptions to not only his production schedule and profits, but selfishly, my personal life. So it got me thinking, what if we could analyze the data collected from those ovens to not only identify patterns, but make more informed decisions about process improvements? So as Rhonda indicated, my name is Michael Hart. I'm here today to talk about how we could do just that, and some essential things to consider as you start this digital transformation. But before we go any further, let's take a bit of a step back and just look at the state of manufacturing. And for decades, manufacturers have been striving to improve their performance and increase efficiencies because this is how success has been defined. And with all the advancements and promises of Industry 4.0 and every opportunity we have, the challenge for most manufacturers is the inability to bring these technologies together. And that's because technology investment is often done in silos with different technologies doing different things, and not working together to allow them to really reap the full benefits they could offer our organizations. Or in some cases, they're even not acquired from the start with the ultimate goal of integrating them across one another. As we think about a smart manufacturing platform, really you take a different approach and take an approach aligned to what manufacturers truly need. As a cloud native solution for over 20 years, Plex delivers a single digital system of record and engagement, essentially one database, one system, one always current software version. It is designed to connect people, systems, machines, and supply chains so that all parts of manufacturing are working together and not in silos that we often see today. Plex automates those business processes to drive efficiency and remove error-prone manual processes and systems. And finally, with a connected automated system, Plex tracks that data from plant floor to the top floor, giving you total visibility to anyone in the company, to any data they need, whether that be production data all the way up to cost data. And finally, Plex enables manufacturers to analyze what matters most to drive more informed decision-making rather than basing decisions on simply gut calls. We believe connecting, automating, tracking, and analyzing everything really is what unlocks the power of a smart manufacturing platform. And with these capabilities, manufacturers gain enhanced visibility to all aspects of the business and deliver higher, more predictable quality, and ultimately have a greater control of their business and their customer relationships. You know, focusing your energy on the right area is also it's important as picking the right technology. From those of us starting our journey, it is often easier to start by solving the challenges closer to our equipment and driving solutions that leverage technology to improve visibility and opportunities for continuous improvement. For others, you may have a solution that controls your quality, your manufacturing, and ultimately your business, and now have the chance to go extend that to your assets to get more connectivity. The important part here is having the flexibility to start where it is appropriate for your business and the confidence really to understand and to know it's all connected. So today we'll focus on the importance of solving the challenges closer to the bottom of this graph, if you will. But why? With all the challenges in today's market, why is it important to change? Why is it important to transition and take advantage of the data around you? Unfortunately, many of us are like my friend. We've all experienced equipment not running as expected and the domino effect it can have on our operations. An unexpected machine break may need to be repaired immediately, causing unplanned downtime, and as a result, decreased equipment availability. A piece of equipment may be operating out of tolerance, causing a high number of scrap parts, which can increase your cost of quality, ultimately resulting in significant impact to your operational KPIs like OEE. The bottom line is the poor machine health can impact each of these plant floor KPIs that you see here on the screen. If I go a step further, we can see all the before scenarios of unmanaged machine health on the left-hand side. Suppose your machines are not operating how they were designed to work. In that case, you can experience unplanned downtime, loss of control over quality, frequent overtime to meet production targets, and an overall reactive approach to maintenance. This leads to the challenges or negative consequences you see on the right here. Loss of production, high scrap rates, lack of competitiveness, increased maintenance costs. The list goes on and on. But as you look at your organization, this is the type of scenario that helps us identify where to go invest our time and our money. But how do we improve? Well, it starts by having actionable data visualized and delivered to the right person at the right time. Real-time data for machine statuses, downtime events, and quality challenges, all delivered through a single pane of glass, if you will, that connects your worker with the expectations of the business. Visualizing operational KPIs to drive more informed decisions, and even more importantly, opportunities to improve based on the advice of your key resources at that asset. So a typical starting point for companies in their digital transformation often begins with connectivity to that diverse landscape on your shop floor, from PLCs to sensors. This connectivity is then visualized as operational KPIs to be consumed by operators and shop floor personnel. This gives shop floor personnel the real-time information needed to make critical adjustments. And at the same time, you're building a foundation of knowledge to support all those continuous improvement activities that allow us to drive change within your business, and it's based on critical feedback and accurate data around the process. So let's take a look at this, say, in the context of OEE, one of the most popular operational KPIs, if you will. In order to be effectively improve this KPI, we need to understand what influences each of the key areas. Availability, we need to answer questions like, what amount of downtime have I experienced on this particular line, this particular asset? What are the root causes of that downtime? Are there any patterns? Does it happen on, is it particular to jobs or shifts or personnel? When we think about scrap, we certainly have questions, similar questions around how much, what are the root causes? Are there patterns associated, again, across jobs and shifts and personnel? And then performance, are we running at rate? Are our expectations appropriate for the business? And ultimately, not just are we running at rate, but what is affecting the performance? So visibility into things like micro stoppages become incredibly important. Under each of these key areas of this one particular KPI, there's opportunities to dig deeper, understand each of them, and certainly dig into the reasons associated to it. This isn't new, right? This isn't new from any of us. But where the opportunity is with real-time data. Real-time data uncovers OEE, but as we saw in the previous slide, the biggest variables for OEE can be unplanned downtime and scrap, often because of availability and quality issues. Closing the loop, we see that unplanned downtime and scrap are often affected by poor asset health. If your machines are not working properly, you're going to experience either high levels of unplanned downtime or scrap or both in many cases. So coming a bit full cycle here, if we improve asset health, we can reduce the risk of unplanned downtime, potentially lowering our scrap rates, and as a result, improve our OEE. But how do we improve asset health? One of the key strategies is to focus on improving your maintenance maturity. So then that begs the question, for some of us, we may not be as experienced with the maintenance maturity model that you see here on the screen. This is a common maintenance maturity model. There are several levels of value that expand from essentially a reactive approach to a predictive approach to maintenance. And as you go from level to level, technology and data requirements increase, certainly with the strategic value you receive. It's important to note, though, that not all your assets should be treated the same. The need to, say, run preventative-based maintenance may be appropriate from some assets, while others warrant a more advanced model. Take, for instance, potentially the light bulb above your desk right now. It's okay to take a reactive-based approach to fixing that particular bulb, where we'd want a more advanced technology to our servers, to our computers, to our assets on the shop floor. So you have a reactive maintenance, which is at the bottom there, essentially running to failure. So let's use the oil changes in our car as an example to kind of paint the picture here of this model. Reactive maintenance would be waiting until that car breaks down, potentially on the side of the highway, before you change your oil. It becomes costly, both from a time and a money perspective, because you break down, you got to call AAA, and then you got to wait for somebody to tow you into the shop, and chances are you probably did even more damage to your engine. Next, you have, say, preventative maintenance. This is the maintenance based on time or usage. So again, Using our simple car example, this would be changing the oil by a certain date or based on how many miles you drive. This is what we're used to doing with our cars, right? We drive 5,000 miles and change our oil, especially my son. This option can be effective in some cases and is probably the right move for your car, but it can be costly because you might be changing the oil too often. And every time your car is in the shop getting an oil change, it's not available for you to use. So your availability starts to decrease as well. And then we have the condition-based maintenance, which is what we're really kind of centered in talking about here today. Using the car example, imagine your car's engine had sensors and they could measure the viscosity of the oil and detect when it's too dirty. It could then alert you that it's time to change the oil to avoid any issues. You have the opportunity then to plan that maintenance based on the data coming off of the car and your driving schedule to make sure you're changing the oil as it relates to your schedule and when it's absolutely necessary. This is where we want to get to with all of our equipment and with equipment that makes sense. Now imagine applying it to those most critical assets. Instead of performing, say, routine preventative maintenance, you can perform maintenance based on data, which allows you to lower your costs and increase your machine availability. So my example today highlights the potential for manufacturers, say, producing gear housings. Their biggest source of scrap is a broaching operation that cuts an inner spline on the middle of that gear housing. As you can imagine, the oil is required to be sprayed to stabilize the temperature of the part and remove any metal fragments during the operation. Now, the really interesting part with this example is the source of scrap has nothing to do with the cutting of the part. Instead, the parts were being scrapped by metal fragments sticking to the conveyor system. The oil gets dirty, sticky, and it ultimately loses its ability to perform its job of keeping the belts clean of debris. And belts with debris on them create scratches on the parts, resulting in them having to be scrapped, which is the biggest point of scrap failure within the facility. Now, try to say that 3 times fast. What are the options for this particular example? Well, you got the reactive based maintenance approach that monitors the scrap rate and performs oil changes to resolve the issues. This obviously drives the potential for high scrap rates and expected downtime, or they could choose a preventative based approach, which would set a maintenance schedule to ensure they remove the potential for any dirty oil ever to be a possibility. That likely would result in increased maintenance costs and lower availability to ensure we combat any of the potential for scrap at that particular work center. Now, finally, they could choose a condition-based approach that monitors that key information coming off the asset and the environment per se to understand how sticky the oil actually is, driving maintenance events from the current reality of that asset. Now, this approach lowers the cost of maintenance, ensuring you are performing events only when required while still maintaining that healthy and reliable asset. See, the reality of the situation is the fact that certain parts create dirty oil as it goes, the environment, more humidity in the plant, other factors can drive the reason for oils to be changed. And of course, they chose to go with a condition-based maintenance event on this particular machine, and as a result, have experienced significant improvements to not only their scrap rate, but their unplanned downtime metrics. So in those examples, right, the companies we're driving towards and have achieved the after scenarios you see here on the left-hand side, like having the ability to capture real-time data on machines and processes, getting early alerts to issues on the machine that are often hidden, and the ability to empower their workforce with visualizations and historical data, and ultimately to drive more proactive maintenance practices. All these desired outcomes on the left ultimately led to the positive business outcomes you see here on the right. So things like maximizing your throughput, lowering your costs with higher quality, improvements to on-time shipment rates, driving an increase in customer satisfaction, and finally, a condition-based maintenance approach that improves productivity and costs. So as I wrap today, in today's conversation, I'll leave you kind of with this final parting notes before we open it up to deeper questions. The right platform allows you essentially to wrap and to extend to solve all these key use cases where the opportunity to connect to your assets is extremely important. And as we think about going back to our organizations, I'd encourage everybody to take the ideas we discussed today, which hopefully they resonate and you can understand how they might be applied back to your business, and understand the capabilities, how they might move the needle in a few of the key areas. One, how would engaging some of your most valuable resources improve your level of understanding? Drive a connected worker engagement. Ask if you put a single pane of glass in front of your operators that gave them the opportunity to understand the expectations of the business, as well as the opportunity to communicate back to the business how to affect change and drive continuous improvement, what type of result would you expect? Not only from the bottom line of the business, but the success and the empowerment and the type of engagement you'd get across your facilities. The truth is the power of actionable data put into the context of the business can be extremely important. Today, we've got much of this data we talked about. It's drived into a historian database somewhere in your facility. And the facts are, nobody actually goes and looks at that data unless you have some type of catastrophic failure. And it's often buried in some catacomb of the plant where you got to go figure out the password and open it up and find the data you're looking at. What would it be to bring that data to the surface, put it in scoreboards and dashboards so that everybody understands and ahead of the tip of their finger? How quickly could you resolve issues, make corrections, and understand the reality of the business? And finally, ultimately drive continuous improvement efforts through process and application improvements that deliver measurable results. Those continuous improvement efforts are focused on data you receive that are actionable and understandable and accurate. And through your worker engagement, you now have a closed loop conversation where everybody's engaged, looking at the same data and driving to improvement across the business. So with that, I'd like to thank everybody for their time today. And I'll pass it back to Rhonda to help us go through any questions or comments the group might have.
Yeah, thanks, Michael. That was a lot of great information. We do have some questions here. I just want to remind everybody, if you did have a question from the presentation, feel free to put it in the chat, and we'll see if we can get to it. Let me look through here, a couple questions. What steps should manufacturers take to successfully implement a solution like this and achieve optimal results?
Yeah, I think the key there is, seen early in the presentation around finding an area where you can focus, an area of challenge within the business, and where you want to go focus, whether that be a continuous improvement challenge, whether that be a challenge associated to asset health, whether that be a challenge associated to understanding dashboards and scoreboards of operational KPIs. Where do you think the right area within your business? And then double click down into it. And as we think about how we implement, there's certainly a technology factor, ensuring that you have the right platform that can not only solve that challenge that you have today, but extend to the next challenge and the next challenge and the next challenge. And that's where a smart manufacturing platform becomes uber important. But the soft area of an implementation is important as well, right? As we think about how we engage the business, how do you engage your assets on the shop floor from a technology standpoint, but also from a human standpoint. Get their engagement, get their involvement, and where we've seen the quickest return on investment and longest success rates are those that engage those workers, gain feedback, and adopt that feedback into the end solution to not only make sure that it works for the business, but it works for the day-to-day capabilities of those workers on the shop floor.
Okay, it looks like we have one more question. How does condition-based maintenance improve equipment reliability and reduce downtime?
Yeah, certainly there's a couple different areas there, right? And go back to the oil change example, right? If you think about a condition-based maintenance maturity model, it allows you to do it when it's appropriate, right? And so through those models, you're typically monitoring particular sensors or information that's coming off the asset that helps us understand how healthy that particular asset is and reacting appropriate for that asset to ensure we eliminate any unplanned downtime. And what we mean by that in practical terms is we're monitoring the time series data coming off that asset, comparing that against threshold settings that ensure it's performing as expectation. And as you cross the thresholds, simple things like condition-based maintenance events can happen, and somebody can go take a look at it. I equate it most to the technology version of what I experience often on a plant tour. And it seems like every time on a plant tour, the person giving the tour at some point during the event stops, kind of walks over to his machine or a group of assets, puts their ear to the ground, the ear to the asset, feels it, and then gets on the phone or talks to somebody that they have to come take a look at it. What we're doing is taking that type of tribal knowledge and making it scalable and repeatable across the assets that are important to your business. And that certainly then obviously removes any of the unplanned downtime events associated to it and lowers the cost of maintenance to which is often the typical response to how do we combat.
All right, it looks like one more question sneaked in here really quick. What are your thoughts on the performance score within OEE in regards to work centers running multiple parts with varied production rates? For example, a work center that has an order of 100,000 parts at 10,000 pph and an order of 30 parts at 1 pph, and how that data skews toward the faster parts.
Yeah, I think that's the key is when you look at operational KPIs to make sure it's tied to the appropriate business and the asset, right? And so having the understanding and the master data configuration to be able to understand the expectation of the business becomes incredibly important. Understanding that this part running through this asset has a different expectation than maybe that same part running through a different asset. And that's where getting that correctly set up on the backside and the business expectations is what allows that real-time visualizations in OEE and the operational KPIs to be most effective. Yeah, so there's there's definitely the need to make sure you handle that complexity into the master data and be able to present the operational business expectations appropriately.
All right, good stuff. Thanks, Michael, and thank you again for everybody that attended our webinar. Look for a follow-up email in your inbox that'll have a recording of this. And again, thanks for joining us today. We look forward to having you at other Plex webinars. Have a great day, everyone.
Yes, thanks, everyone.